So what do we have now? We have this question. Still, we are still discussing connectedness. So we have two topologies, tau 1 and tau 2. We have two topologies, tau 1 and tau 2 on a topological space on a set A, whereby tau 1 is a subset of tau 2. We have tau 1 being a subset of tau 2, and there are two topologies on A. So we want to establish whether the following statements are correct. If this space here is connected, does it imply that this is connected? If tau 1 is a subset of tau 2. Now, tau 1 being a subset of tau 2, tau 1 is a subset of tau 2. This implies that open sets in tau 1 are in tau 2. Open sets in tau 1 are in tau 2. So let us see. So we have, let us first investigate this first statement. If suppose that a tau 1 is connected. Suppose that a tau 1 is connected. What does that imply? That if it's connected, then this implies that we have no open sets. We have no open sets in tau 1 forming a separation of A. But this is what we have. Open sets in tau 1, they are in tau 2. So this is tau 2. This is tau 1. Now we cannot, since A with tau 1 is a connected space, so we cannot find open sets here which form a separation of A. We cannot find open sets there which form a separation of A. But if we cannot find them here, if they do not exist here, it does not necessarily mean that they cannot be established within tau 2. So tau 1 cannot be having open sets which can be expressed in such a way that they separate A. But that does not necessarily mean that we cannot find those sets in tau 2, because we can actually find one here. We can find this one here. This is a set. And you can also find another one here in such a way. Yeah. So this implies that tau 1 connected does not imply that tau 2 connected. Now let us investigate part 2. Part 2, which is this. Now we are going to suppose that tau 2 is connected. Suppose that it's connected. So this implies that there exists no open sets in tau 2. There exists no open sets in tau 2 such that they form a separation of A. We cannot find open sets in tau 2 in the bigger topology such that they form a separation. This is tau 2, this is tau 2, and this is tau 1. So the whole of this is tau 2. We cannot find sets in tau 2 which form a separation of A. Since tau 1 is also in tau 2, this implies that such sets, such open sets do not exist. Do not exist in tau 1. The rain is coming. Do not exist in tau 1. Such open sets do not exist in tau 1, implying that A tau 1 is connected. A tau 1 is connected.